Today, students, we talked a lot about how to solve exponential logarithmic equations. So, a couple things we talked about is our first rule is if we have the same base and it is set equal to each other, and it's one term on one side and one term on the other, then I can go ahead and I can just cross out my bases and set 3x is equal to x minus 8. And then solve for x. And in this case, x is going to be -4. Over here on B, this one we did in class today, but we have to look and we have to compare 4 and 8, and we have to see, can I make these have a base to an exponent? And most of you guys saw in class 2 squared is equal to 4 and 2 to the third is equal to 8. So I'm just going to substitute that in for 8 and take it to the x power. And then I'm going to substitute 2 squared in for 4 and take it to the x plus 1 power. So in this case, I have 2 to the 3x is equal to 2 to the 2x plus 2. And so, same basis, I can just set them equal to each other. Minus 2x, so x is equal to 2. And that will be your final answer. C, you do the exact same way. I can see that I can take, instead of it being 9, I can say 3 squared. That's going to be the x plus 8. And then I have 3x. So then I can do away with my bases. So I'm left with x is equal to 2 times x plus 8. So x is equal to 2x plus 8. Subtract x. So if x plus 8 is equal to 0, subtract 8. And I have -8 is equal to x as my answer. Here I have 5 to the 3x plus 1, and I know that 25 is 5 squared, so I take it to the x plus 1. So I have 3x plus 1 is equal to 2x plus 2. And I subtract 2x, and I subtract 1, and I'm left with x is equal to 1 as my answer. So that's dealing with ones where I can make them the same base and then just set the exponents equal to each other. My next type of problem to solve is one that deals with changing it back from exponential form to a logarithmic form. So let me just write my formulas up here, and it looks something like this. B to the x is equal to a, and I take log base b, a is equal to x. So if I have 8 as my base, I take log 8, and I know a is 23, so I'm going to put that there, and I'm solving for x. And at this point, I can do the change of base formula. Log of 23 divided by log of 8 is equal to x. I plug it into my calculator, and you can find out what x is equal to. My next situation is kind of the same situation, and you need to go ahead and plug this into your calculator. I'm just trying to make the video a little bit shorter. So you plug in log of 23 divided by log of 8, and you will come up with your answer. In this situation here, I do the exact same thing. Log base 2 of 50 is equal to x plus 1. And then I have log of 50 divided by log of 2 is equal to x plus 1. And whenever I plug that into my calculator, and I'll actually do this one, I plug log of 50 into my numerator and then log of 2 in my denominator, and that's going to be equal to 5.64 is equal to x plus 1. So then I subtract 1 from both sides, and x is equal to 4.64. And that is your final answer. Same type of situation for C, same type of situation for D. But in D, I'm going to subtract 1 from both sides, so I have 6x is equal to 36. And you know that 6 squared is equal to 36, so x is equal to 2. But if I didn't, you could use the log formula. The next ones are kind of similar to what we started with on the front page. And if I have 2 problems and they're the same base, log to the same base, then I can just alleviate my logs and do x plus 7 is equal to 5x. And I subtract x, and 4x is equal to 7, and then I divide both sides by 4. You do the same exact thing for B and C, and I asked you guys to do that for homework tonight, and I know you can do that. It's not hard at all. The next ones were a little bit more difficult. I did A in class, so I'm going to start with, I'm going to do B. So here, the situation is it's an addition sign, and I want to condense that side of the equation. So when I say condense, I do log base 6, and then I have x, and then I multiply x times x minus 5 is equal to 2. So I have log base 6 of x squared minus 5x is equal to 2. From here, I do 6 squared is equal to x squared minus 5x. So I have 36 is equal to x squared minus 5x. And then I subtract 36, and I have 0 is equal to x squared minus 5x minus 36. And from here I do the x factor. And I think I can do -9 and +4. So I have 0 is equal to x plus 4 times x minus 9. I said x plus 4 is equal to 0, and I said x minus 9 is equal to 0. Oh, x minus 9 is equal to 0. So x is equal to -4, and x is equal to +9. Now, I have to see if this actually works. So I need to plug it in to my calculator and see if it works. So I can say log base 6 of 16 minus 20 is equal to 2 is log base 6 of -4 is equal to 2. And I don't know if that's correct. So I have to do log of 4, -4, oops, log of -4, and divide that by log of 6. And it doesn't work. So -4 cannot be an answer, but I might have done that incorrectly. So I have 16, oh, plus 20. So I'm sorry. So it would be log of 6, 36 is equal to 2, and that is correct. So that one's right. And then I plug in 9. So I do 81 minus 45. So log of 6 of 81 minus 45. 81 minus 45 is equal to 36. Is equal to 2, and that is also correct. So both of these solutions work out perfectly. So that'll hopefully get you started and get you to where you need to be for tomorrow's class.